Okay guys, this is a really good review of curve sketching. It covers a whole bunch of different things, so let me just walk you through the notes at the beginning. First talking about straight line motion, moving to the right, moving to the left. We usually are given S of t as the position, or it could be x of t. And then the derivative of that is the velocity. And notice the absolute value of the velocity is speed. And the second derivative is the derivative of the velocity, which is the acceleration function. And you know you can go backwards too using integration. Now it gives you a little chart to help you when velocities increasing or greater than 0 and acceleration is greater than 0, it's speeding up. When acceleration is greater than 0 and velocity is less than 0, it's slowing down. This is when the signs are the same. So here's when the signs are the same. They're both negative here, and they're both positive here, and then they're opposite signs here and here. Now it also tells you that if acceleration is 0, then you have constant velocity to the right, and if it's greater than 0, velocity is greater than 0, and if velocity is less than 0, you have constant velocity to the left. So if velocity is 0, it stopped accelerating, and listen. If velocity is 0 but acceleration is greater than 0, the particle stopped, but it was accelerating right. And if its velocity equals 0 and acceleration is less than 0, it stopped accelerating left. And when they're both 0, it stopped and there's no acceleration. That's interesting. We usually don't use these two, but it's nice to know you understand it. Here's two attempts to find the maximum height of an object. You set v of t equal to 0 and then solve for t, and then you find s of t because it wants the height, not the time of the height. To find the velocity of an object when it hits the ground, you set the height, or s of t, equal to 0 and solve for t, and then you substitute that back into v of t. So it could be several steps. So make sure you understand these two really clearly, okay? All right, now for curve sketching, this is that whole thing about increasing, decreasing. When the derivative is positive, the original graph is increasing, okay? When the derivative is 0, there's a critical point, so it's switching back and forth. You have a horizontal tangent line. When the derivative is negative, the original graph is decreasing. Okay, now then you can add some more things. When the first derivative is positive or increasing, and the second derivative is positive, we have concavity. It's concave up. When the critical point is the derivative, we take the derivative function and we can use that. This is a maximum of max of the first derivative. We have a 0 or undefined slope. And concave down, it would be decreasing and negative. Okay, so what's the next little note? Okay, these are interesting to tell you how to find the maximum and minima. So if you want to know if to find where f of x is increasing and decreasing and the maximum and minima, you find the first derivative, find all points where it's 0 or undefined. That's your critical points, and places where it's undefined. Those are called critical points. Make a rough sketch of the function and use the sketch to determine which intervals are negative and positive. And that's like your end behavior sign chart. And if the derivative changes from positive to negative, you have a relative maximum. And don't forget, if it's negative to positive, you have a relative minimum. It's been a while since we've done this. Concavity is where you take the second derivative and set it equal to 0. And these are all possible points of inflection. And you guys periodically have gotten that wrong because you just say it's a point of inflection. But remember, we can have a graph that just touches or something like that, and then that would be negative and negative, no point of inflection there. So you would sketch a rough draft end behavior and see if it's concave up or down. When it's negative, it's concave down, and when it's positive, it's concave up. If it changes from positive to negative, so right here, this would be a point of inflection. This would not be a point of inflection. Right, and moving on to the curve sketching justification. So if it asks for increasing, you know that f of x is increasing and decreasing from x to y because the derivative is positive, negative over that interval. Okay, so that's what you say, remember? And extrema, I know that this is a relative minimum or maximum because it's the point is a 0 of f of x, and it changes from positive to negative or negative to positive. So that's like, hey, what do I write in my FRQs for justification? And I think I've gone over that with you, but this is just a review of it. Okay, concavity, you would say, I know it's concave up or concave down because the second derivative, or if you only have the first derivative, you'd say the first derivative is increasing or decreasing. Or if you can take the second derivative, or they give you the second derivative, is that positive or negative? So either of these work depending on what's been given. This is usually the one. You look for the first derivative and see where it's increasing, and that'll tell you the concavity. Point of inflection. Okay, I know I have a point of inflection because the point is an extrema of the f prime of x, or I know it's a point of inflection because f prime of x is a 0 and it changes sign. Okay, so opposite signs or something like that. So we can cover point of inflection too. So study those. And the last thing for sketching tips, here's the 4 things you do because we're going to start sketching these. Number 1, you find any roots, y-intercepts, horizontal or vertical asymptotes. That's of the original function. Then you test the first derivative, find the critical points, and where it's non-differentiable to see if there's cusps or corners. Then you can take the second derivative, set that equal to 0. That will show you all the possible points of inflection and show you concavity, all right, where the graph curves up and curves down. And then you can test the end behavior. What will the general shape of the graph be? If you know end behavior, it should help you. So I'm going to stop this first part of the video and go through the examples on the next one.